We talked a bit about how we can use pooling in the previous week about OTP. However, we're going to go in depth more and really understand pooling a bit better. Essentially, we can use pooling to increase our bottleneck width that we talked about happening in processes in our previous video. Essentially, what pooling is at its core is fixing this issue of having a caller trying to request to a process, but only having one process to request to. Instead, we have a process manager, which then has access to multiple processes. For our caller makes this request to the process manager and gets returned an OK with PID. It then uses that PID to interact with the process directly and call whatever it needs to on that direct process. This allows it to be extremely scalable because that process manager isn't really doing much outside of handing back PIDs to the caller and keeping track of which processes are in use. It is not doing a lot of heavy lifting as those processes might be, which then allows it to be very quick. There are a few pooling libraries available to us inside of Elixir, and those are Poolboy, NimblePool, dbconnection, and PG/PG2. Poolboy is very easy to use, and I recommend using that most of the time because you can get away with it and it has a very easy interface. You can also see it being used in a few libraries such as HTTP Poison. I haven't actually used NimblePool before, however all of the Nimble tools that are released on GitHub have been really great to use so far, so I think this is one of the good options as well. dbconnection is used in Ecto, and you'll see that being used in other driver-like situations where you have a long-running process that's connected to a database. Something like Scilla connectors can often use dbconnection. PG/PG2, the reason why it has a slash is because PG2 has recently gone back to being named PG, and there's a tiny bit of confusion here because PG used to exist and then got taken out and replaced with PG2, and then PG2 had decided to go back to PG. It's a bit of a confusing history there, but in essence, you're looking at PG2/PG. You don't often see these being used directly because they're a bit more manual and involved. You actually have to create process groups and join those process groups together, whereas NimblePool, Poolboy, and dbconnection kind of handle all of that for you. So if you can, I would recommend using one of those three libraries. Now let's go over an example of using Poolboy. So in this case, we have our myapplication.myworker, which is just a simple gen server that can use a function called doThing. This doThing is just a handle call, which in turn sleeps for a second and just returns OK. Now this is not normally code we would write, but just to example it, pretend that we have a gen server that takes a second to do our thing. To convert it to a pool, instead of defining myWorker inside of our application supervisor, we define our Poolboy child spec, and we define a name for it called myWorker, as well as the fact that it's going to have a local name of myWorker, and then we set our worker module to be myapplication.myworker. We also set the pool size to be 2, as well as a max overflow of 2, which will allow for a total size of 4 if absolutely necessary. Next, we can then use that name that we set for our Poolboy child spec to call our poolboy.checkout and get a PID back. We can then call our myworker.doThing to do our long-running function, and then check back in the connection using poolboy.checkin with the name of that pool. We can also set false here as a second parameter to checkout, and what that will do is set it to be non-blocking. That means if all the workers are full dealing with other requests, instead of waiting for a PID, we'll just return a tuple of full. In this case, our code would actually break because we're just assigning PID here, so we'd probably want a case statement to determine whether or not the pool was full, and if it is full, do our own retry logic, or maybe just return a backup result. Now this is great, however there's another way we can do this without relying on our poolboy.checkin that's a tiny bit more fault tolerant. We can use our poolboy.transaction function to take in the name again, and then take in a function which takes out a PID and has a timeout. In this case, we have our PID being passed into the function, and then that can be passed into the doThing. And so we simplified our steps here by using a function as opposed to having to manually work with the PID and check in and out. In this case, Poolboy checks out and checks in automatically. We also might be wondering why we have a timeout. As we discussed with having false as the second parameter, we can have a situation where the pools are full. So say for example, we have a process manager and we have 2 processes, and both these processes are currently under load from 2 callers. In the situation where we now have a third caller, it's going to be unable to handle this new load because two processes are already being used and you only have a size of 2 and there's already 2 callers addressing them. Instead, what we're going to have is a timeout. And so if those processes take too long to complete, our caller is just going to get a timed out message. Or if we have a non-blocking request, it's just going to happen instantly and we're just going to say that it's not working. Pools are a really great strategy to increase the amount of load that your system can handle and increase the limitations of your processes, especially given that processes are essentially single-threaded. You can increase those threads by having pools. However, there are still some limitations that you need to be aware of. You need to have enough worker processes available. As we just saw in the previous video where we have 2 callers and 2 worker nodes, those 2 worker nodes are filled up by those 2 callers and can't adapt for a third node. We can also use max overflow if we don't need the processes to be kept alive or around necessarily, and they can be spun up as an overflow situation. We also need to be aware that the pool manager process can get slow and eventually start to build a message queue. If you're really hammering that pool manager, it can eventually back up and become the bottleneck itself, even though it was created to replace that bottleneck. A simple strategy here is to actually just create multiple pools and have a enum.random select which pool you're using. That way, it's kind of round robin and evenly distributed across the different pools that you have. And that way you can't also overload your pool manager. The final thing to be aware of is as you add more pool size, the CPU usage will grow. It's not just going to be a free resource, you're going to use more CPU cycles the more pools you have available. And so the CPU usage might grow with that. So you have to be aware if your CPU is growing too much and maybe you just need to add more CPUs, or potentially it might be time to start thinking about horizontally scaling and moving out to another server.